Cascade-Zero123 methods aim to extend a 2D latent diffusion model to the 3D scope. However, the generated images of these methods are not geometrically and visually consistent across different views. It is challenging to synthesize high-quality novel view images when the camera pose changes dramatically, incurring completely unseen parts. In contrast, Cascade-Zero123 progressively extracts the 3D information from one single image via self-prompted nearby views. Cascade-Zero123 shows strong capability on various complex objects, such as insects, robots, or multiple object stack. Here we will give a brief introduction of the structure of our Cascade-Zero123. Given a 0-1 to 3 model, the diffusion model's forward process adds Gaussian noise n. And then 0-1 to 3 has proposed a conditional latent diffusion model to learn relationships between camera poses during the denoising process. Then we can model the view condition of the input image in the camera pose space. After that, we sample some rotation and translation matrices of the nearby viewpoints. With inference of base 0-1 to 3, we can get these target views as xt1, xt2, xt3, and so on. After obtaining the multi-view images generated by the first stage base 0-1 to 3 and their corresponding camera poses, we proceed to compute the camera pose rotation changes for each of these images with respect to the final target image. Finally, all these images are set as condition image for the second refiner 0-1 to 3. After the model is trained, we can get the refined target view. After each training iteration, base 0-1 to 3 network is updated in a momentum update way using exponential moving average (EMA). Here we provide some novel view synthesis compared with 0-1 to 3 XL and SyncDreamer, where 0-1 to 3 XL is 0-1 to 3 pre-trained on Objaverse XL datasets, achieving higher performance. We selected some challenging scenes, including stacked objects, parallel objects, and objects multiple branches. 0-1 to 3 exhibits good quality in image generation but lacks consistency in these complex scenes. SyncDreamer, on the other hand, demonstrates good consistency but struggles to maintain good quality in image generation. Our model maintains both quality and consistency in these scenarios. We also show single image to 3D reconstruction results using DreamFusion SDS loss. The proposal of self-prompted views has enhanced the ability of 0-1 to 3 to model the shapes of multiple objects and occluded objects. The back of ice cream can also be refined and the shapes of Beauty Ninja, white chess are well preserved. The occluded rocket fins can also be modeled. Even the slender pear pedicle improves. In addition, Cascade-Zero1 to 3 can correct the problem that the 0-1 to 3 model sometimes learns inaccurate colors of the backside. The ears of the fox, the back and hair of Lisa have been improved. And the back of the dinosaur should not be learned as the same color. The top of the little Batman's head is learned as pure white. However, it should be black. The smoothing problems on the back of the glass tiger and the glass bottle of honey have also been improved in detail. Moreover, 0-1 to 3, when combined with SDS, has difficulty modeling objects with transparency or high brightness. 0-1 to 3 sometimes learns the backside of transparent objects as pure white clouds. However, the multi-view conditioning information prevents the model from lacking information about other sides, avoiding the learning of a pure white plane for the backside.